Well, hi again, everybody. Welcome to my latest video. Well, actually, this is going to be sort of an unexpected upgrade to my high-end AMD PC that I recently built. You've probably seen, one or two of the videos in that series. I had planned on ending it with the last video, but I had the chance to buy a processor. That's a considerable upgrade for this one. And at the same time, I realized, and I'll show you some of the test results as I go into this, that the power supply I put in here is really insufficient. The 750 watts just is not enough for a system with the type of CPU and definitely the type of graphics card, which is the NVIDIA GTX 3080. So what I'm going to have to do is replace that power supply. Unfortunately, I don't have another white one. I'm going to have to put a black 850 that I have in there. So the aesthetics of this is going to be messed up slightly, but it's more important for me to make sure that it works reliably than how it looks, to be honest with you. So anyway, let me go ahead and make the changes to this, and then we'll see what happens. I've also done some testing of the performance in terms of the heat that I had not tested last time, because it's important. The new CPU I'm putting in there may generate considerably more heat. And I also want to make sure that the power supply is doing what I expect it to do once I put in there as well. So if you get something out of this video that you find useful or helpful in any way, again, I would appreciate it if you at least consider subscribing to my channel. Okay, what I was able to get from Amazon was this Rosewill Gaming 80 Plus. I'm going by the full name they have in the ad there. Hive Series 1000 watt power supply. Again, I'm going by my general golden rule of thumb when it comes to proper power efficiency and effectiveness. If I have over 500 watts being drawn, which I do, then I need a power supply that can handle that by about a factor of 2. So this particular one should do that. Okay, so we have the Hive Series power supply, 1000 watt. And as you can see, it is capable of supporting 996 watts for the 12 volt. This is the thing I point out on all power supplies that I've reviewed on my channel, because very little wattage is drawn from these other ones, so to count those into that 1000 would be inappropriate. So this should be more than enough to handle the power that's being drawn by that PC, even with a GTX 3080 and the new CPU that I'm putting in. It's also fully modular, so I'll be able to be selective on the cables that I use, and thereby making cable management a little bit easier. I'm not going to take away from the fact that I have to actually completely break my cable management. All the work that I did on that is going to have to be reversed for the most part. I'll have to try to find my magic wand to try to help me with that again. The power supply comes with all of its cables, a very, very thick power cable, as you could imagine. And then I have a variety of the individual cables that will go into this. A little bag, a nice little handy little bag to store any cables that I don't use. Okay, here's the other piece that's going in. It's a Ryzen 9 5900X, one of the latest series of Ryzen processors that have been released. Now, I actually showed this box before, but on this particular video, I want to show you real quick, opening up the box and show you that there's not much in here, quite honestly. Most of it is cardboard, big piece of junk. They don't give you the cooler when you get certain types of Ryzen CPUs that would not be properly cooled by the standard issued Ryzen type cooler, even at top of the line. So they even tell you here that it's compatible with the AM4 socket, but they go into some detail in terms of, you have to put another cooler, an aftermarket cooler on it, which is what I'm going to do. That CPU already has a water cooler in it. I'm not going to change that, so it'll still be that water cooler. I just have to pull the CPU chip out and put this one in, which is what I'll show in this video. Before I go any further, I better update the BIOS. So I'm into the ASUS EFI BIOS utility, and I have copied the latest BIOS, which is, I think it's version 3405, yes. And I'm updating it right now. This is a critical step since I am upgrading this PC with a new AMD processor line from a new generation, and I have to make sure that it will boot up when I put the new CPU in there. At the end of this update, I have to go and also check the configuration, because sometimes an BIOS update will change some of the standard configuration that you've done inside of your BIOS. Things like, putting in a memory profile and such. As I said before, when you update the BIOS, it's critical to make sure that you don't accidentally lose power. I always plug the system into one of my UPS protected outlets that I have attached to my desk that I've shown in a previous video. You have to make sure that you don't lose power, or you could brick the motherboard and you'll have to return it back to the manufacturer. Okay, successfully updated. Now we can reboot. Oh, a message. BIOS is updating LED firmware. Do not shut down or reset the system to prevent system boot up failure. Okay. Booting up. Oh, now it's telling us to boot up with F1 to go into the BIOS, which I was going to do anyway. And here we go. We're now in the BIOS. And as is expected, the DOCP has been disabled, so I will re-enable that. This is in effect doing an overclock of the memory, which is what we want to do here. So we'll accept that and reboot. Back in the BIOS again, just to make sure it's now enabled. Looks good. So at this point, we can just go ahead and save the changes and move on. See if Windows comes up. Good sign. Yep, that little spinning wheel. And we're up. Windows is up, so I didn't break anything by updating the BIOS. That's great to see. Okay, I got a pretty major job here. I got to pull all of this cable management out, pretty much. But the only thing I think I'll leave initially, but I may have to still take it out, is this bundle of addressable RGB cables down here. I may not have to touch that, but everything else is going to have to be coming out. The power supply is coming out, all of the power supply cables, these white cables, the flat ones and the round ones, any of the RGB associated with the power supply, obviously the SATA drive cables. It's going to be a major overhaul, because I'm not only changing the CPU, but in order to do that properly, I also got to pull out the graphics card, and I also got to pull out the 240 millimeter all-in-one cooler. So anything, even these RGB cables up here, are going to have to come out because of that. At least the cable ties associated with it. But I'll go ahead and speed through most of this pretty quickly. Okay, I think I got most of it disconnected now. Let me start unscrewing the power supply from the side here. That's all I can get from the back here. I'll have to do the rest from the front at this point. Okay, now I got to remove the actual all-in-one water cooler in order to get to the cables that are behind there that I need to change. And I might as well leave it off as I change the CPU. Okay, I've decided to try to leave the video card in because I don't want to have to remove these front fans in order to get the bracket off that's holding it to the case. I think I can work around it. Let me remove some of these cables with the actual pump connector. I left one screw on to the cooler, and now I'll take that off so it wouldn't fall into the thing. Because I want to get to this cable here as well, so that's why I'm doing it this way. Now I have to get the pump off. It's got two screws. You got to twist the pump when you're taking it off. You don't pull straight up, or you could pull the CPU right out. Loosen the screws. You got to sort of twist this. Okay, it seems like it's disconnected. There we go. There we go, the pump is disconnected. And you can see the CPU still intact, it's in its socket. I'm going to clean it off a little bit before I take it out of the socket. Okay, I've got my 99% isopropyl alcohol here. Got some paper towels. Okay, let's take this 5900X out. There we go. Take this guy out. Put him in a safe place for a few minutes. Now I take the 5900. Put that in. Again, make sure that you line up the arrows. Be very careful not to drop it. So it's in. Give it a little bit of a side to side and back and forth here. And holding it gently down with one finger, lock it in place. And that's it. The new CPU is in. Now I have to replace the cooler. Before I put the cooler on, let me give it one little quick clean with some more alcohol, just to make sure there's no fingers on it. A little bit of a polishing here. And before I put the pump back on, let me put some more thermal paste in here. Give myself that little pea-size one. That should be it. Get the pump. It's got these two levers on both sides. We've got to maneuver them into the bracket as best we can, and keeping it going straight down as we do that. A little bit of a trick to this thing. Try not to touch the platen of the thermal coupling that's on the bottom of the pump. I'll get one end in first, and then as I got that in, I'll try to maneuver the other end in. And they're both in now. So now it's above the CPU, and I'm going to start tightening it by hand. Try to go down evenly as you can. Want that thermal paste to spread out nice and even. So we're trying to get it in there as flat as possible, as level as possible, and tighten it up. Get them as tight as I can by hand, and then we take a screwdriver and we finish the job. Little bit, back and forth a couple of times, and that should be it. So the pump's back in. I'm going to go ahead while I got it cooler out. I'm going to take off the cables that are connected to the motherboard. Those are the ones we were missing before. And then I can push those back into the other side of the case. And what I'm going to do is reverse the process. Before I put the cooler back in, I'm going to get those CPU connectors up through there and reconnect them. So I have the power supply sitting here. It's got all the cables attached already. I'm just going to run the two for the CPU up to that same little corner while I have it with the cooler out and lying up in a safe position. And I'm going to feed them right into that little corner there and get them in place before I put the cooler back. I've already cable tied them together all the way to the power supply. It's still difficult getting those jobbers in there, I can tell you that right now, but much easier than it would have been if I had tried to do it with the cooler still in place. Okay, now I can get the cooler back on. I had to disconnect all of those cables in the back for the RGB, so that's going to be a major rebuild on that. But I have everything now up here that I need up here, and this radiator can go back in. I'll leave some extra room. I'll try to level it off towards the front a little bit more so that we have more cooling capability for the VRM. I'm going to try to keep it away from there as much as I can. Okay, there you go. The cooler is back in place now. Now I'm going to start pulling some wires to the back and start some cable management back there and put the RGB back together. Okay, let's get the power supply in now. Again, these are the screws that actually came with the power supply. You should always use those because they're the proper length to prevent a short. And it's in. Now we're just a matter of running some cables, plugging them in, and a lot of cable management. Okay, well I got everything in now. I got it partially cable managed. I cable managed all the black cables from the power supply and a few miscellaneous ones. I did hook up all the RGB. Not sure if it's all working yet or not. I think I'll just try it and see what happens. Let me turn the power supply on. It's already plugged in. Oh, I see lights. I see the lights from the motherboard. That's a good sign right there. Okay, let me hit the power button and see what happens here. I see lights. Let me go to the monitor and see what that looks like. There it is. It's coming up on the monitor. And it's into Windows. Wow, that is unbelievable. I thought it'd be much harder than that. I really did. Okay, I guess now, let me see if I can log into Windows. Bring this around. I'll just do this. The camera looking at the screen right now and see if that works. Okay, let me log in. I'll turn the mouse on. I don't have the mouse on right now. The mouse is not on. Okay, it's waiting for me to log in. Let's see what happens. Oh, there it is. It's going in. Let me try a real quick one here. So I'll just try Heaven. Anyway, the machine looks like it's working. I'll have to now, get my magic wand and finish up the, the cable management, and then I'm ready to do some testing. So here's my final back cable management. It looks pretty good. It's always a challenge to get everything nice and neat, but I think this one worked out. Okay, now let's view the performance testing results. In this first chart, I'm showing the results of Heaven Benchmark. Now, I not only included this workstation, but my existing workstation and my previous backup workstation. So you do see a noticeable improvement here. Now, in this case, I ran Crystal Disk Mark. I did not expect any improvement at all here, but apparently the faster CPU does help because it picked up, quite a few little bits. Now, here's the Cinebench test results. Now, this also includes the previous PCs. But as you can see, a noticeable improvement here. Now here are the 3D Mark results. Now I found that 3D Mark is one of the most reliable overall performance tests. I even used it to do the heat testing with later on in these charts. Now this workstation is obviously meant the primary role as a video creation workstation. As you can see, I did the video rendering test and it was significant. This is going to be a great video creation workstation. Well, we've seen the benefit. Now for the first cost. Obviously, the utility power is one of the areas that we're going to suffer a little bit. The new 5900X draws a lot more power than the existing 3900X, as we can see in this chart. Then further along those cost lines, here's the resulting temperature increase of the entire PC, mainly driven by the new PC, the 5900X. As you can see, we picked up a few degrees in terms of the CPU heat, but not the GPU heat. Then finally, this chart summarizes overall all of the testing and benefits and costs that I've just talked about. The ones that I've labeled with the green percentages, those are improvements, and the ones that I've labeled in the red percentages obviously are the cost associated with getting those improvements. Well, I think that does it. The upgrade of my new high-end editing and PC rig, the replacement to my backup editing rig. As you can see, this is right now considerably faster than my existing primary daily driver, but we'll see. I got some changes coming for that very soon in terms of an upgrade to that one. Pretty much almost a complete rebuild, actually. Anyway, if you got something out of this video you found useful, if you could at least consider subscribing to my channel, it'd be really helpful. And then you'll be able to see future builds like this and other things that I do that are related to computer technology. So until the next time, take care, be safe, and be healthy.